Okay, this video is a similar video to those I recorded corresponding to the reorder points, but for the fixed period policy, where I'm going to explain briefly what happens when we have a fixed period which is smaller than the lead time, which is similar to what happened to the reorder points. This is an example which is the same for the BQ problem I have in this playlist, and I've changed the standard deviation to 20 because I want these numbers to be okay. In the previous video there was an error because the standard deviation for the let me see. Okay, yes, the standard deviation, well, we had a 200 here, we should have this standard deviation, but when that happens we have this weird behavior, which is nothing wrong. The problem is that since we have a demand that I have to truncate, we have things like that. So for us to understand the very basics, I reduced the standard deviation for the week so that I have a small deviation for the hour, for the hourly demand, and we see a behavior like this. Okay, but I just wanted to know that there was a mistake there, although the explanation was right with the numbers we had for the hourly demand. But again, there was no correspondence with these two values. Okay, so let's go to the fixed period. In this case, we have this weekly demand 300, the standard deviation for the weekly demand 20, and the lead time, which is 2 weeks. And I have the numbers here for the daily demand and the hourly demand. I have prepared this to see what figures were better, and I'm going to go with the hourly demand. So I have a row per each hour in the time horizon I'm representing in this graph, and these are the values for the mean and the standard deviation for the demand, the lead time in hours. And I'm going to set these values, which are the ones that you would obtain if you wanted to get a 95% cycle service level. This is wrong. Okay. What I'm doing here is the reverse calculation. Well, we have the demand for the lead time plus the fixed period, and that deviation for that lead time plus the fixed period. And we have the safety stock, which is the difference between the order up to level and the demand corresponding to the lead time plus the fixed period. We can do things this way. So if I decide to have this order up to level, the implicit or the safety stock I'm setting is this. So we do the reverse calculation, it still holds. And I can do the fraction, I can divide the safety stock by the standard deviation, and I get this K. And with a normal distribution, standard normal distribution, I can get what is the probability of that normal distribution being less or equal than this value here, which is the cycle service level. So I'm reproducing the calculations here in a reverse way, but they are correct. The point here is that when I have this fixed period, which is 56 hours compared to this 336 hours for the lead time, we have a similar behavior for the one we saw for the reorder points, because they basically behave the same way when it comes to deciding to place orders to make sure we are not going to run out of stock given this probability we set. The thing is, I'm going to show you I'm going to change these numbers, okay, just for making the explanation clearer. I'm going to set a fixed period. This is the optimal policy if you do the numbers corresponding to this data here. This doesn't mean I cannot do things differently, and the behavior of my on-hand inventory and on-order inventory and the total inventory also is valid. So I'm going to set an order up to level to, let's say, for a fixed period of 180, which is roughly half the time, the lead time. So we'll still have this behavior where we have at least one order to be received. I'm going to update the values. When I do this, what I say is that I have stockouts, because if I have this order up to level, since I changed the fixed period, I changed the demands and the standard deviation during the lead time plus the fixed period, and now I have a negative safety stock. So we are expecting a very likelihood that I will have stockouts on every cycle. So I'm going to change consistently. I have my cheat sheet here, and I'm going to write an order up to level, let's say this. So what I'm doing is, okay, I'm placing orders when these hours have passed, okay, and I'm going to order up to this amount here. And the basis to, oh, I have the calculations here. Let me just explain this. I have row per hour, the demand per this hour, per every hour, and we have, as in the previous video, we have the level, the on-hand inventory, and the on order. The difference here is that we are going to place an order. I'm going to have a first order place here. That's what I said, this blue color. And then I have this formula here that makes sure that if this is 150, no, in this case 180 rows down, I will get another one somewhere here. There we go. And that will mean that I'm going to place an order which is different between the difference between the order up to level and this inventory level, which is the summation of what I have on hand and what I still have to receive. Okay, and a 180 rows down, I'll have another order placed. There we go. And again, I compare this value here, which is the summation of my 100 inventory and the on order inventory with the order up to level, and I place the order, which is the difference between those two values. And that is the way to decide when to place orders. And when I place an order here, I have these rows, which is, in this case, I'm not using this one. I'm going to use a light gray. Okay, I'm using this formula here that finds values corresponding to Q, to quantities placed in the past, and and anytime I find an 8 here, which is the order I just placed, which is the difference between this order up to level and my inventory level, this 1192, I'm going to find these 8. In this case, my lead time is 336, so 330 somewhere here. There we go. Where is my, I should see the quantity somewhere here. Let's see. Let me see that again. I placed this 8 here, so this is row 7, so somewhere like 342 in that row I should find the quantity I ordered, and there we go. Yes, because it was just one figure, so this is the 8 I'm looking for, and so it goes for the rest of the orders I placed. So that is the way when I received, I compute that I've received the amount I order previously. So that is how the calculations are done. But the thing is, now what I do is when I place my first order here, I need to make sure that I'm going to have enough inventory with this level I'm ordering up to, so that I can cover my demand during the lead time plus the fixed period. Okay, and this happens here because the time that goes from here to here is the lead time, the fixed period, and then from this point to here, to this instant here, this is the lead time. Okay, and we can see that once I have placed the first order, I get to a point where the fixed period has occurred, has elapsed, and I have to make a place in the order. And again, now I need to have a lot size. I have to place an order with a quantity which is equal to what I need to set to this order up to level, and this value is constant, and is that allows me to give it with a given probability, okay, to be sure that we are going to have enough inventory, again given that probability, which is very high in this case, so that I don't run out of stock for the time until I can have I can see the effects of my next decision. So here I place the order, and gets consumed the inventory, and I can decide again later on, and that will have an effect here. So since what I'm deciding here has an impact later on in this instant, I have to make sure that I have enough inventory for the demand from this point during the next periods corresponding to the fixed period, and then for the time corresponding to the lead time. So once you forget about what is the mechanics of this policy, the same thing occurs. So the point here is that when you are ordering, although you haven't, when you're here, although you haven't received, for example, this order you placed that will be received later, you know that you will receive that on time, and you can take that into account for you to decide how much you order to replenish up to this level, which is this, in this case, this 1200. Okay, so the point here is that you always have to look at the inventory level, okay, no matter whether you have it on hand or on order, because what you have on order will be available prior to the moment when you will receive what you are placing here. So you can take into account or take for granted that what you've placed before as an order will be available for covering the demand. So you need to make sure that you need to place orders with enough quantity so that you are okay during the fixed period plus the lead time. And this happens again, although it's more difficult to see it because we have more peaks in between. When we have these values here, I can recompute, which is what we had previously. Okay, so these peaks here are shorter because I'm ordering more often, but the same applies. So anytime I'm going to place an order up to this level, I'm going to make sure I have enough to fulfill my demand from this point till the next fixed period plus the lead time. Because all these peaks I have here and I haven't received yet, I'm going to receive them before that happens. In this case, well, this is the fixed period, the lead time is much longer. It's all this, so I have to take a look at this fixed period plus something like this a segment here, which is the lead time, because during this lead time I'm going to receive the orders I placed before. The effects in this chart is less obvious, but the mechanics are exactly the same as where we had when we had these numbers. And finally, if I have a fixed period which is larger than the lead time, this doesn't happen anymore. Okay, if I do this, well, I'll be in trouble with the inventory. Okay, I compute that. I have stock outs because I'm ordering. You can see here the effect that if I make I use a larger fixed period, the standard deviation of that demand grows, so the uncertainty is larger, and my safety stock has to increase as well. And the way to increase that is ordering up to a higher level. So if I tap here, let's see, this will work fine. Now what I see is what we are used to, we saw in class. So we have this inventory level, we order up to this amount so that we can make sure that we'll be okay for the time between placing orders plus the lead time. Okay, so I hope this complements the explanation about what happens when, in this case, the fixed period is smaller than the lead time. Okay, and that you always have to take into account how the inventory level is, so that you place an order to replenish up to a given value, taking into account the inventory level and not only the on-hand inventory. Okay, again, I hope this helps. Bye bye.